For thousands of years, one star has stood out among the countless lights scattered across the night sky. Glowing with a distinctive reddish-orange hue, it occupies a prominent position within the constellation Orion, making it easy to recognize even without a telescope. Generations of skywatchers have noticed it. Ancient civilizations recorded it. Travelers used it as a familiar marker during long journeys beneath the stars. Yet this remarkable object is far more than a bright point of light. Behind its calm appearance lies one of the most extreme stars known to astronomy, a colossal stellar giant nearing the end of its existence. Today, scientists know this star as Betelgeuse. Located roughly 640 light-years from Earth, Betelgeuse belongs to a rare class of stars known as red supergiants. These are among the largest stars that exist, dwarfing ordinary stars like our Sun in both size and luminosity. Although its surface temperature is lower than that of the Sun, its enormous dimensions allow it to radiate an extraordinary amount of energy. To appreciate its scale, imagine placing Betelgeuse at the center of our solar system. Its swollen outer atmosphere would stretch across vast distances, engulfing the inner planets entirely. Mercury, Venus, Earth, and Mars would disappear inside the star's enormous envelope. Even Jupiter would orbit dangerously close to its outer regions. Numbers alone struggle to capture such immensity. Betelgeuse is not simply large, it exists on a scale that challenges human intuition. But size is only part of the story. Unlike smaller stars that maintain relatively stable conditions, Betelgeuse is constantly changing. Its surface is a turbulent landscape of rising and falling plasma driven by immense convection currents. On Earth, weather systems can span continents. On Betelgeuse, individual convection cells can be so vast that entire planetary systems could fit inside them. These gigantic currents transport energy from the star's interior toward its surface, creating bright regions, dark regions, and ongoing fluctuations in brightness. As a result, Betelgeuse appears to pulse. Its light increases and decreases over time, giving astronomers valuable clues about what is happening deep inside the star. For centuries, these variations puzzled observers. Today, they are understood as signs of a star struggling to maintain balance. At every moment, two powerful forces compete within Betelgeuse. Gravity attempts to pull all of its matter inward. At the same time, energy generated by nuclear fusion pushes outward. For most of a star's life, these forces remain in equilibrium. But as massive stars age, maintaining that balance becomes increasingly difficult. Betelgeuse is currently experiencing this late evolutionary stage. Deep within its interior, nuclear reactions continue transforming lighter elements into heavier ones. Over millions of years, hydrogen was converted into helium. Helium produced carbon and oxygen. Successively heavier elements formed as temperatures and pressures increased. Each stage brings the star closer to its ultimate fate. And that fate is unavoidable. One reason astronomers pay such close attention to Betelgeuse is that it is expected to end its life in a spectacular supernova explosion. A supernova occurs when a massive star can no longer support its own weight. Eventually, an iron-rich core develops deep within the stellar interior. Unlike previous fusion reactions, iron cannot release energy through fusion under normal stellar conditions. When enough iron accumulates, the star loses its ability to resist gravity. The collapse begins. In a matter of seconds, the core compresses dramatically while shock waves race outward through the surrounding layers. The resulting explosion releases an astonishing amount of energy. For a brief period, a single star can outshine billions of others. When Betelgeuse eventually reaches this stage, it will become one of the most remarkable astronomical events ever witnessed by humanity. The explosion will be visible without telescopes. It may remain visible during daylight hours. At night, it could shine brighter than any star currently seen in Earth's sky. Yet despite its dramatic appearance, there is no significant danger to our planet. The star is far enough away that the explosion would be a magnificent spectacle rather than a catastrophe. Still, one question fascinates both scientists and the public. When will it happen? The honest answer is that nobody knows. In astronomical terms, Betelgeuse is nearing the end of its life. However, that final stage could arrive tomorrow, centuries from now, or tens of thousands of years in the future. Predicting the exact moment remains impossible. This uncertainty became especially apparent during an event that captured worldwide attention. Between late 2019 and early 2020, Betelgeuse experienced an unprecedented decrease in brightness. Observers around the globe noticed the change. The star appeared dramatically dimmer than usual. Because astronomers had long expected Betelgeuse to explode someday, speculation spread rapidly. Had the process finally begun? Was humanity about to witness a supernova in real time? Observatories quickly focused their instruments on the star. The answer turned out to be surprising. Rather than exploding, Betelgeuse had ejected an enormous cloud of material from its outer layers. As the expanding cloud moved between the star and Earth, it blocked part of the light reaching us. The star itself remained active and intact. It had effectively hidden behind its own dust. The event provided a rare opportunity for scientists to study the behavior of a red supergiant in extraordinary detail. And what they learned reinforced an important fact. Betelgeuse is far more dynamic than previously imagined. Massive eruptions continue to reshape its atmosphere. Powerful stellar winds carry gas and dust into surrounding space. Its outer layers expand, contract, and evolve in ways that challenge existing models. Every new observation reveals additional complexity. Yet perhaps the most fascinating aspect of Betelgeuse is what it represents. The elements being expelled from the star today will not simply vanish. They will become part of future generations of stars and planets. Carbon, oxygen, nitrogen, and other elements essential to life are produced within stars like Betelgeuse and eventually released into the galaxy. In a very real sense, the atoms that make up living organisms originate from ancient stars that died long before our solar system existed. Betelgeuse is participating in that same cosmic process. Its future destruction will also be an act of creation. The materials forged during its lifetime will enrich interstellar space, contributing to worlds that have not yet formed and stories that have not yet begun. For now, the giant remains visible above Earth, shining from its place in Orion. Its brightness fluctuates. Its atmosphere changes. Its interior continues the slow processes that have shaped it for millions of years. And somewhere beneath those turbulent outer layers, the countdown toward its final transformation continues. Whether that moment arrives in our lifetime or far beyond it, Betelgeuse serves as a reminder that the universe is never truly still. Even the stars that appear constant are changing. They are born, they evolve, and eventually they transform, recycling their substance into future generations of cosmic structures. One day, Betelgeuse will write its final chapter across the sky in an explosion of unimaginable brilliance. Until then, it remains one of the most fascinating objects humanity can observe, a stellar giant suspended between stability and collapse, carrying within it both the history of the cosmos and the seeds of what comes next.